Our next speaker now is the CEO of the startup IIoT Oxys, Cliff Emmons. IIoT Oxys is one of our 1,800 startups that are part of our MIT Startup Exchange program. Through the Industry Liaison program, we connect our members' company with many startups of our database toward mutually beneficial engagements. IIoT Oxys Incorporation is a technology company at the intersection of the industrial Internet of Things, AI, and machine learning, edge computing, and manufacturing operations. The company's algorithms help its customers implement Manufacturing 4.0 and achieve its benefits, higher quality, performance, and productivity at lower costs. Today's presentation will cover a few examples of successful customer engagement, and we'll have time for technical questions in the Q&A. In the Q&A, the co-founder, Chandran, sorry, I don't have his last name, will jump in last minute, so he'll be able also to participate in the Q&A on the side of Cliff Emmons. So thank you very much, Cliff, for sharing with us a presentation of your technology, and the floor is yours.
Excellent. Thank you very much, Daphne. Greatly appreciate that introduction. And I'm just turning on my screen so that everyone can see it in presentation mode. And just waiting for it. Oh, there it goes. There it goes. So once again, thanks to everyone on the call today. Thanks very much to John for that great keynote discussion. I'm very excited to present to you our company, IIoT Oxys, and just want to really, again, thank the ILP as an ILP Startup Exchange company through one of our co-founders who is a research scientist here at MIT. We have found the relationship between the Startup Exchange and the ILP extremely valuable, and it brings great value, I think, to its members in the ILP. So with that, let's continue to talk about Manufacturing 4.0. I think one of the themes that you could really see from what John was saying today is, while we all know that we want to get to that promised land of Manufacturing 4.0 and all the benefits that come from it, there are a lot of challenges when you have to really roll up your sleeves and make it happen. And I think it's great that John was talking about how it really means getting down to the shop floor and interacting with the people, with the owners of the processes to make this come about. So kind of looking at those challenges and talking a little bit about them, really hoping that they resonate with some of the things that you've seen. First of all, many of you are working in highly regulated industries where changing a process means that you could be changing a validation of a process. And that's a big deal. In itself, it could be a loss of time and productivity. So you need to have companies that are familiar with the whole process of pharmaceutical and med device manufacturing and other highly regulated industries like aerospace. Also, many times it's just simply that you're not able to get the data real time to the people who need it. And it's also about how well can you actually have these different types of AI and machine learning insights interface with the actual subject matter experts so that they can actually truly have insights that they can actually use to either improve the processes or do some type of interaction with them if things aren't going right. But we do believe that at the end of the day, the thing that will happen and progress this forward is first by creating connectivity that produces data, and then using machine learning and AI to create those benefits. And that benefit is, of course, what I would call the optimization of the performance, cost, quality triangle, which essentially is all of productivity. And if we take a look at what our technology at IIoT Oxys provides, very many times what we're focused right at is improving quality and improving machine uptime. And when you combine those factors and the positive aspects of those two elements, that's really where performance, which is the third leg of the triangle, quickly follows. Our engagement model is extremely simple. First and foremost, a consultation, because you can't solve a problem unless you understand it. That means interacting with the actual subject matter experts, the people that many times have known these processes, whether they're discrete or continuous. Many times they're the ones that have created them at the very beginning and have been with those processes for decades. The second part is to actually see what data has actually already been gathered that you can potentially gather insights from. Many of this, much of this is the usual quality data and manufacturing productivity data already gathered through maybe traditional offline methods. The example I'm going to use in just a bit is a great example of unused data. There was actually 2.5 years worth of data on the particular process we worked with on this client that had not been analyzed, simply because the manufacturing operations people are simply too busy to be able to spend time looking at data. They need a partner. The phase 2 is really the pilot implementation. This is where, after learning what the problem is, taking a look at the initial data, we're able to formulate, can we actually simply just use the different types of data that is coming in, the sensors, the PLCs, the controllers in the system, or do we need to augment them either with maybe some minimally invasive types of sensors like power monitoring, or some very direct measurements like accelerometers or acoustic sensors. Then finally, through the pilot process, being able to show the basic value proposition of the advantages of having those insights as the processes are actually taking place real time and over time, then it's possible to put together a long-term strategy with the client and be able to look at what the long-term system approach would be, in addition to a software as a service usual subscription model, so that they can easily get those insights. We feel that what is happening in all of our industries is that data science is beginning to get democratized, where almost every single subject matter expert is starting to get data science types of skill sets. But there is going to be, I think, still a long transition for this. The purpose of IIoT Oxys and our professional services is to interact with your subject matter experts and basically help them understand the data science and the machine learning techniques, many times that start with physics-based approaches and classical types of control theory that then can be augmented with strong data science. Here I just kind of lay out what is a very top-level type of systems approach that we use in creating that first pilot system and then moving to a long-term implemented system to both extract that data and actually process it real time and deliver it to your subject matter experts so that they can either intervene or that they can take long-term changes to the process for its improvement. As you can see, it starts with a discrete or continuous process, as stated down in the lower right-hand corner. It usually involves all different types of machinery, anything from plastic injection molding machines to CNC machines to custom semi-automated equipment for assembly. And then in the case of continuous systems, any number of batch processes that are used, say, in the biotech or pharma industry, not exclusive to just the processing of the actual materials, but also into the actual potentially discrete assembly and packaging processes. The key is that we're able to either utilize the sensors or the data that is coming into the PLC and the controllers in these machines and equipment. We can augment it, as I mentioned, with these non-invasive power monitoring sensors. And through that, we actually are able to extract that data, many times pipe it into the cloud with the proper security measures, or into private servers, where then we can access it with our machine learning engineers and begin to develop the algorithms and the insights. The second part of that process is either an extended pilot where we actually then create this local edge computing so that we can begin to do real-time analysis of the data and provide real-time insights, or it might be part of the actual implementation final phase. And as I mentioned before, a key element in all of this is the idea, another theme that John touched on was the rapid expanse of computing power that's available to us really has begun to take systems that originally were not being able to be processed in real time, and now more and more be able to do that actual computing and delivering those insights to the shop floor as the processes are actually taking place. Here I just name a few of the things. Something as simple as a Raspberry Pi is all that's needed sometimes, but other times powerful computing power like a field programmable gate array out of Xilinx or a GPU from NVIDIA is needed to implement these types of programs. I'm going to touch again now on the case study I was referring to earlier. We're under NDA with this customer, so I can't tell you exactly who this the company is, but it's a Fortune 500 pharma company that has capabilities here in Cambridge as well as in Asia. This was a piece of equipment that was aging. It was starting to break down more frequently, and the team was really getting impacted by this loss of productivity. We came in, we found that they had, through our exploratory process, that they had actually been gathering data for 2.5 years but had not analyzed it. That allowed us to go into that phase one, the exploratory analysis, where you can see the heat map that was generated from hundreds of variables. It allowed us to begin to understand the process and relate with their subject matter experts as far as the different types of issues that had occurred. We then applied some good physics-based methods to actually narrow down those parameters, and then started using more advanced machine learning methodologies, classifiers, boosted classifiers, to actually produce the predictive results that you see here, where we're actually able to help them begin to see when actual batch processes were starting to go south and predict if it was going to be a good or a bad batch. But this also has created the groundwork for predictive maintenance on the machine, because many times this variance in the actual process was actually leading up to what was going to be a maintenance or a breakdown issue in the future. So now now that we've completed the successful pilot, we're engaging the customer to look at an implementation of phase two with the real-time analysis and employing the same techniques to help them with predictive maintenance. The other thing that I wanted to share with you today was I made one of the best decisions I have since I've been CEO back in March. We brought on a very strong partner in the area of AI and machine learning. The company is called Eingura IIoT. You'll see that they're part of a large European conglomerate that actually is involved in machining centers that are used around the world and definitely in many automotive applications. We've been working on several Manufacturing 4.0 projects together, both in the US and Europe. And it's been great because we have complementary skill sets in target industries. So I'm going to talk a little bit about the second use case with Eingura's technology. Again, I think they've really added additional capabilities from the sensor and hardware and processing, real-time edge computing capabilities. They also have definitely done a lot of work with pulling information directly off of PLCs and the controllers for discrete manufacturing like CNCs. We plan on applying it to also plastic injection molding machines. So all of these things fit into both continuous as well as discrete processing applications. The use case I'm going to share with you is as you can see, automotive crankshaft off of actually one of the parent company's CNC machines, Exitar, which is the part of the conglomerate that Eingura is part of. So they actually worked with their parent company and the client on an issue of significant downtime on a CNC machine. Here are definitely the idea you can see here, lossage up to 2 hours per day. That's very, very bad as far as productivity. The solution that had been used in the past was not producing the insights. They had lots of data, but no knowledge. Sounds a little bit familiar to the pharma example I was stating earlier. They came in, they added additional sensing capabilities. Here you can kind of see some of the actual things that they actually looked at, the data size that they used, and I think sampling rates along those lines. Here are some of the actual results from the machine learning techniques that they applied, and you can see almost a 10% improvement in availability. So I really would like to invite everyone that's on the line that is a manufacturing engineer or an operations leader. Definitely, we have great experience in the automotive, aerospace, biotech, pharma, and medtech industries. While I say here medium to large size companies, I think is our sweet spot. We have also worked with smaller companies, and we've worked with, as I mentioned before, Fortune 500 companies. So I'm really looking forward to getting your questions, and in case somebody wants to ask some really deep machine learning questions, I also have my lead algorithm engineer online, Chandran Sesagiri, as Daphne mentioned, and I also have the CTO from Ingura, Javier Diaz, ready to help answer your questions. Thank you.
Great, thank you, Cliff, for this insightful presentation on it. Could you maybe talk about a little bit your unique selling points, and when does it make sense actually for a company to actually engage your services and your solutions on it? Because you talked about really using machine learning, installing sensors. So when is the best application for a company for that?
I think the greatest point about this is look to where your problems are right now. Look to the particular manufacturing line that is giving you the most trouble and the greatest amount of downtime. Look at then within that space, what is the particular element of the process? Many times this is cell manufacturing, so it might be just one particular station, in a discrete assembly process that's causing problems. In the case of the pharma industry, many times when you don't have, you have limited capital, so you can only choose a particular type of, a certain projects. What you really need to do sometimes is look at the aging equipment that maybe with this additional technology can extend the life, can improve the productivity for it long enough so that you can do the other high priority projects, within your total plant or operational plan, and then essentially be prepared to then utilize this technology on the brand new equipment once the old is replaced.
Okay, great. So what is the typical implementation times, or from the idea a company decides to implement it on until it's up and running, and is there any disruption of the production machines in between?
So the first phase is the consultation phase, and even the analysis of historical data is great because it can run real time, in parallel with absolutely no disruption, to the current processes. We have found that many times the consultation could be done as quickly as 4 to 6 weeks. Many times we've also been able to turn around historical data, initial studies within about the same period of time, 4 to 6 weeks. Sometimes a little bit longer. It is dependent upon how much data there is, and what do we decide are the critical elements based on our engagement with your subject matter experts, the real process knowledge people. As far as the pilot, pilot stage, we have found those easily go from 3 to 6 months. Usually you want about 3 months to put together the right design of the system, implement it. That is the point where you need to coordinate it because you're basically doing the installation. Then again, it's really usually 2 to 3 months following where you're beginning to gather the data to establish the value proposition of the pilot. That will be done in the course of normal operation. and without any interference to the current production. The final implementation will only interrupt the actual process if indeed there's some augmentation, say, of those edge computing devices to do real-time insights. But for the most part, it's going to at least be no more or similar to the minor disruption of the installation of the pilot equipment.
Okay, great. Thank you. So I assume you're looking for customers, also looking for investors, and who should be the person if somebody's interested to contact your company?
Well, the great news about us is, even though we are a startup, we're an early stage company. Unlike many companies in the greater Boston area that are the private route, we actually are a public company and have been a public company since 2017. We're a publicly traded company on the OTC, over-the-counter Pink Sheets. We are a tiny microcap, but you can actually trade on our actual in stock through the OTC. But we are planning expansion of the company where there will be opportunities through other traditional public offerings to invest in the company.
Super. Well, thank you very much for presenting on it. So I assume, Daphne, that we're going to move on. So giving the word back to you. Thank you, Cliff.
Thank you very much.
Oh, there we go. Unmute. Thank you very much, Klaus. And again, thank you, Cliff, and your team. Our next speaker. Sorry about that. My video is not on. Sorry. Our next speaker is the co-founder of the startup Gen1, Christopher Davis. Gen1 is also an MIT startup, part of our MIT Startup Exchange community. Gen1's core value is developing scalable, lean prototypes of electromechanical devices. This encompasses engineering disciplines from industrial to embedded systems to software. Christopher Davis is principal and co-founder of the company. He holds a BS in chemical engineering from MIT. Thank you very much, Christopher, for sharing with us a presentation of your company.
Excellent. So everyone can hear me, right? Excellent. Nice to hear from everyone. Everyone can hear me, right? Good.
Yes.
We are good to go. And I'd just like to give a quick thanks to Daphne, Klaus, and the rest of the ILP team. It's really a boon to smaller, newer companies like ours to be able to rub shoulders with industry giants that are grappling with really tough technical problems that we really like to sink our teeth into. So I give heavy thanks to that. It's been a really awesome program. But I'm just going to dive right into it, keep it very light. So as said before, my name is Christopher Davis, and I'm managing co-founder and principal of Gen1 Technologies. We're a local design and development house based right here in Cambridge, Massachusetts. And our big thing is developing scalable prototypes. We like to playfully refer to ourselves as nerds for hire. We started in 2015 from work directly stemming from MIT, and since then we've built a small, nimble team that encompasses a ton of different engineering aspects, from mechanical engineering and electrical engineering all the way to embedded devices, embedded systems, and web apps. Because of our integrated skill sets, we very heavily focus on smart devices. Now, the term is relatively recent, but they've existed in one form or another for almost since antiquity. We help companies actually prototype and create these smart devices, as well as at the end of the day, once the prototypes are done, create plans for scaling those up from, say, 1 or 2 prototypes all the way to, say, 100 or more. In the earlier stage of a given project, we have a very heavy focus on rapid prototyping technologies. So things like 3D printing, commercial off-the-shelf electronics, Raspberry Pis, quick turn manufacturing, as well as things like Heroku, very quickly scalable product concepts. And that enables us to be very nimble and fast while still having a very wide skill set. Now, Cliff and John have already gone into a ton of detail on this, but very briefly, what is a smart device, right? Just so we can get all the definitions straight. Well, broadly, what it is, it's a device that can collect data and perform some action remotely. This could take the form of, a small box that you put in a factory to collect, sensor data, or it can be something you put out in the field to collect, low power, but not always. Traditionally, these devices sported low power processors that at the end of the day, they sent data to some endpoint like a computer or a server to do the heavy computational lifting. But this was years ago. Now in 2020, you can do a lot more processing on board. And this is actually becoming our focus here. This is really nice for data intensive applications, like anything where you're dealing with streaming video, anything in real time, machine vision, sensor fusion. You now have the ability to get the same insights, but you're sending a lot less data at a given point in time. So it's cheaper because you're sending less data, but you can also be a lot more flexible with network topology, and you can get a lot more interesting technologies into the mix that aren't necessarily meant for high bandwidth. So like things like, say, LoRa networks and BLE, you're able to actually do that. Our past experience spans the gamut when it comes to working with projects. We've worked all the way from individual and first-time inventors to Fortune 500 companies. We've done prototyping for fields and robotics and medical devices, all the way to machine vision and enterprise-level medical infrastructure, where you start to really worry about things like security, HIPAA compliancy, where you're sending your data and how it's getting from point A to point B. And that's been just an amazing journey, just from start to finish. Now, I've told you a little bit about what we do very broadly, but I'd be remiss if I didn't go into what we've actually done in the past. So I'm going to get right into this. So one of the coolest projects we've worked on, this was actually a couple of years ago, but a client came to us with a very interesting problem statement. They wanted to use the shared economy model and apply it to gym equipment. So think about being able to get to like a kiosk or a set-top box and rent, gym equipment. So like, jump ropes and basketballs, footballs. And we went back and forth, basically looking at concept ideas. And at the end of it, we created an electronic locker system that allows for a given subscriber to do exactly that, check out exercise equipment. You can do that with a mobile web app and a tablet app, and it's sitting in South Boston. In fact, the second one is actually being built a little bit closer to Cambridge. Now, how this guy actually works is it communicates using cellular 4G data with a tablet, and it communicates with a given customer using a built-in hybrid app to control the locker and actually allow access to various things. We've designed the mechanical enclosure, all the electrical components, so that includes PCB design, schematics, sheet metal design, collaborated with manufacturers to actually have these big devices built, which are huge. And we've also, on the back end, created an analytics application for the owner of a given locker to track what equipment is being rented out and make adjustments on the fly. So if something's not being used so much, you can swap it out basically and use something that's a lot more popular with consumers. So that's one of the projects we worked on, but this is personally one of my favorites because I've worked on this and it's really cool. So a client about a year and a half ago came to us with a very interesting problem statement. They wanted to figure out how to do real-time asset tracking, so figuring out where something is without the ability to use technologies like GPS. They knew what they wanted, but they didn't know what technology to use. We took that and we bounced it around the company, and we basically said, hey, there's a lot of technologies available, but we want to use the new Bluetooth Energy 5.1 standard. It's actually still in development. It isn't totally finished yet, but they still have dev boards and stuff for that purpose. It uses something called an angle of arrival, using multiple receivers to triangulate the position of something in real time and send it somewhere else. And so we use dev boards from Texas Instruments to basically create a proof of concept that consisted of hardware and firmware and an Android native application to really give to the client and see and allow them to test out all this stuff on the fly and very quickly because we use commercial off-the-shelf components. This is more of a medical application for what we've done. So a client came to us basically saying that, okay, people who are older, they have a lot of medications to take in a given regime, and it all has to be done in a specific order on certain dates. But because of the fact that they're older and the fact that they have busy lives and things like that, it's very tough for them to actually stay adherent to a certain regime. And so they said, how are you going to be able to do this with IoT technology. So we eventually settled on this, where it's a physical device that sits on your desk that allows for access to certain medications. It talks to the internet and gives back and allows access to certain medications based on what day it is, and it takes out the stress of having to basically figure out what medication goes on which day. And it texts the user to figure out, okay, to remind the user that they need their medication. And so we gave them that physical prototype, and as an added bonus, since this was just one prototype, we researched things like HIPAA compliancy and security to ensure that once we start making more of these, that the data is going where it's supposed to be and that everything is being safely done. When a project comes in the door, our approach is actually very simple. We define what the problem is, we create it, a mock-up, and then we scale it up and deploy it. Very often our clients come to us with some kind of problem that needs to be solved, but they don't know exactly what technologies to use. And this is where we come in. This is actually a large part of our job, is to boil it down into an MIT-style problem statement with benchmarks and constraints that have to be met. And we take out everything else, because at the end of the day, the less complicated your product is, as John says, the more robust it is and the less likely it is to have errors and things. So after that, we go into the mock-up phase, which I think is actually the fun part. You go in and you actually start to build things with the 3D printing and the Raspberry Pis, and you create a mock-up that addresses the most challenging aspects of the product. We do it with off-the-shelf tools, and then we basically test and iterate until it's completed. From there, we go from 1 or 2 prototypes to, say, hundreds or more. This is where we start to get in a lot of our manufacturers, our PCB manufacturers, our 3D printers, etc. Injection molders. This is where we really start to scale things up. At the end of the day, our ask is, if you're an engineering leader, such as a principal engineer or a VP of innovation who's thinking of validating or refining an existing offering, automating an internal process, or building a new product, we want to talk with you, especially if your work involves sensing, PCB design, automation, machine learning, and telecommunications. And with that actually ends the official part of my talk. My contact information is above. I thank you guys for your time, and I open up for questions.
Well, thank you, Chris. Very info side on it. One of the questions that actually came up when you talk about smart systems and IoT, and there's 5G networks are actually coming about and getting rolled out. You see them rolled out in Europe, you're rolling them out in the United States with no latency. So what's that going to do to IoT and smart devices?
Sure. So we get this question a fair bit. And one thing to consider when you're talking about, IoT systems, when you're talking about 5G systems, is it's not really one standard. There's actually multiple concurrent standards that are being rolled out at once, all under the 5G label. And it's not totally finished. So you can buy dev boards and equipment that address it, but that can change in the future. But knowing what we know now, we know that for certain, low data throughput applications, such as, if you're just sending out, say, temperature data, you can actually do it using a standard known as 5G IoT, which, while not having super duper low latency, very, very cheap. And then you have, traditional the 5G that people think of, where, very low latency. This is where you start to get into things like, video streaming, really high, really dense data applications. And it allows you to put them in, more places with more technology and do it a lot simpler than before.
Okay, thank you. Let me look at the other questions on. Yeah, so what technology stacks actually do you use in?
Sure, so that's very project dependent. But at the end of the day, we like to really focus on, our major stacks tend to be commercial off-the-shelf equipment, right? But when we're developing our products, oftentimes they need to interface with a web app or something on the phone. And for that, we use what they call the mean stack, which consists of MongoDB, Express, AngularJS, and Node. And that allows us to basically prototype things that can fit on a smartphone, that can talk with our various microcontrollers efficiently and very quickly. Our team has a lot of experience with that. When it comes to actually creating the firmware that lives on these devices, embedded systems almost always talk in, some kind of C variant. So it can be, C, C++ sometimes, and that's usually what's used for our prototyping applications.
Okay. So how do you scale actually your IoT devices and smart devices? Do you put them in a mesh network, or what's the best way of doing that?
Yeah, so again, very much project dependent, but we like to always think of, okay, cool, so the first thing we always say before you scale is, are you sure that what you're creating solves the problem you want to do exactly, right? You have some flexibility nowadays because you can update things like firmware in the cloud, but at the end of the day, you're limited by what your hardware can achieve. So that's always the first thing that I like to say. When we actually start scaling up these products, we bring in various partners who have a lot of experience with, they have the connections in China, they can source, a lot of parts for way cheaper than you can get here, and they have those connections. So that's the first thing. Secondly, when it comes to, going from say 10 products to thousands, your network infrastructure also has to be really robust in order to handle the volume of data coming in. So if you have something that say talks to a server and it's doing it in a semi-real time, right? We would usually use something like Heroku, which, very, very fast. It allows us to be nimble when it comes to prototyping. But when you scale your devices up to a certain degree, now you're thinking of, more enterprise level systems like AWS and things like that. So a lot of considerations at once. But we always like to say, before you make the step to scale up, make absolutely sure that you've done your customer validation, you've done your homework beforehand, because changes after that tend to get very expensive.
Now, you showed a couple of samples you've been working on for some of your clients on it now. So if you had to choose something, what would your preferred project be?
A perfect project, what?
Your preferred project to work on?
Oh my gosh, a perfect project to be. So we actually, when we look at our products, oh man, this actually makes me really happy because so many. But when we look at the stuff in the team, we always like to go by the mantra of do good while also doing well, right? So something that ultimately benefits humanity in one part or another. We really like to excel in those projects that have a real meshing of not only embedded systems, but also mechanical parts. So like there was one project we really like, we can't go into a ton of detail, but what it effectively is it's used for sports. So, you have to, create the enclosure for the electronics so they can, withstand very rough conditions, make sure that the user can use it very well, but also basically have everything very robustly created. And it was awesome because it really got us to push, the limits of our knowledge. And that's where you really tend to learn the most. And you find that, you have different projects or different application use cases, but at the end of the day, the core, how should I say, principles and technologies very often remain the same. So, really just those out there projects we really love.
I think I have an idea. I talked to one of a company in the forestry industry that wanted to monitor the growth of their trees, and that might be a perfect application for IoT and smart devices.
Oh, yeah. We like putting microcontrollers in places where no one thought they could before. So,
well, thank you very much, Chris. That was very interesting. So, give the word back to Daphne, which is going to do a couple of closing words.
Indeed. Thank you very much, Klaus, and thank you very much, Chris. So this is the end of our webinar. Again, it's the first webinar in a series of 4 webinars on the Manufacturing 4.0. So if you're still online, I just remind you the dates. The next is Tuesday, October 13th. Then it's Tuesday, November 10th. And Tuesday, December 1st. You can find all the information on our website. And again, any follow-up, please reach out to your program director. We'll be very happy to connect you with the startups or the MIT speaker who you saw today. Thank you and have a very good weekend, very good rest of your day. Goodbye.